Chapter 7, Section 1 is simplifying rational expressions. So first off, what is a rational expression? It's a fraction containing polynomials for the numerator and denominator. In addition, don't forget that when we're working with a fraction, the denominator is not allowed to equal 0. Remember that when the denominator is 0, it's called undefined. So in our first example, when it says to determine the value or values of the variable for which each expression is undefined, what we're looking at is the value or values which will make the denominator equal to 0. And so what we do in our fraction is we take the denominator, set it equal to 0, and solve. So x equals -2 is where this expression is undefined. On part B, we have a little bit more complicated of a denominator, one that needs to be factored. It's a difference of squares pattern. So we're going to have two answers. So we're going to say that x equals -4 and +4 are the answers where that expression is undefined. Next, we're going to evaluate. Evaluate is just the same as it is in any other chapter that we've done so far. You're going to substitute the given values in the appropriate location and then simplify using correct order of operations and simplify the fraction. Next, we are going to simplify rational expressions containing variables. To do so, the first step is to factor everything, numerator and denominator. Then we're going to reduce any and all common factors. Just as a note here, when you're reducing, it must be the entire factor, not just pieces, and I will show you what I mean by that when we get to some examples. Another note, sometimes a factor will be backwards. So if a common factor is backwards, then we're going to factor out a -1 to make it match. So what I mean by that is if I have x minus 2 and 2 minus x, so 2 minus x is backwards. We're used to seeing standard form, which has the variable first. What we're going to do is we're going to take this backwards factor. We're going to factor out a -1, which is like dividing by -1. And then by the commutative property of addition, I can flip that around. So we have -1 times x minus 2. So when we're looking to reduce, we'll have x minus 2 reducing with x minus 2 and leaving out an -1. So let's simplify some of these. Factor So when I took the numerator, it's a GCF. The denominator is a monomial, so no factoring. Then you simplify your fraction and the x, so these x's are going to cancel. And 3 and 27, that's 1 and 9. So now we have x plus 3 over 9. And this is as far as our problem can go. As I mentioned earlier about not canceling pieces. So this 3 and this 9 do not reduce, because this 3 is a piece of the numerator, x plus 3. If it's ever connected with an addition or subtraction, you cannot cancel just one part of it. So this 3 and the 27 could cancel because they're connected through multiplication. So that's why the 3, it's 3 times x, and it's 27 times x, whereas this is x plus 3. On part B, factoring the numerators, the squares pattern. The denominator is a trinomial with a number in front. So I'm going with trial and error. 14 is just 2 times 7. It's 4 and 7. So if I take a negative 7 plus 4, that makes negative 3. Then the x plus 2's cancel. So we have x minus 2 over 2x minus 7. On part C, the numerator is another trinomial with a number in front. 4, it's either 4 and 1 or 2 and 2. I'm going to go with 2 and 2. Negative and negative, so that makes a negative 6, negative 8, z in the middle. Then this is backwards on the denominator, so I'm going to put a negative 1. Then I'm going to flip it around to z minus 2. So then the z minus 2's cancel, and I have 3z minus 2 over negative 1. But I can't leave the negative 1 in the denominator. I'm going to shift it to the numerator. Then I can't leave my answer with these parentheses, so I'm going to distribute the negative.